All right, this is section 2.1. So a lot of this is based on your spaghetti lab that you have started. So these questions, what was represented along the x-axis of your function graph? So if you remember, you made your spaghetti lab. You had your unit circle that you made with your piece of spaghetti as your radius, okay? Then you put your x and your y-axis through the middle of your circle and extended it and then made a new y-axis down here, okay? So the function graph is this part, and they want to know what was represented on the x-axis. So what numbers or things did you transfer onto the x-axis of that function graph? So those were your angles. If you remember, you put your string around the circumference of the circle, laid it flat across that x-axis, and then transferred your angles onto that function graph, okay? So those are your angles that you took from the circumference from that piece of string you wrapped around and then straightened it back out. The y-axis of your function graph, so this part, okay, the highest part, if you remember, was 1, and the lowest part was -1 because it came from your circle. So it came from your radius of your circle, okay? It was the distances from each angle to the outside of your circle. What length did you transfer from the unit circle to the function graph? So you transferred your y values first. Okay, so your y values, which remember y is sine. Okay, and they were your distances vertically. Okay, so we went from the x-axis up, or from your angle down, I guess technically. We had a 30, a 45, a 60, and we would go from each of those angles vertically down to the x-axis, and it was these distances that were then transferred onto your graph. Okay? Here, 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 so on and so forth. Those vertical distances. Okay, so which lengths represent based on what we have done in the past, and that was sine. Okay, because those are your y values. Okay, all that good stuff we've already done. We're just going to put some vocab to all of this today. Nothing really too complicated, just some words we're going to need to know and be able to use in the future. Period and amplitude. So period is the length of your function all across the x-axis before it starts over again. So we have graphed, with our spaghetti labs, we graphed one period of sine, one rotation around the circle, okay? And one rotation is highlighted in red on here, goes from 0 to 2 pi. So it takes a full rotation, 360 degrees, or 2 pi radians, in order to get through the entire thing. However, we know that we can go backwards on our circle into the negative angle, so that would continue if we decided to. We can also keep going and have angles that are bigger than 360 and continue to rotate around that way. So the sine function never ends, because you can keep going around and around and around in this circle, and this wave will just continue to repeat itself. What we're looking for is period, which is when you have just one rotation. How long does it take to do that rotation? So as long as we're not altering anything, which we aren't yet, your period is going to be 2 pi, because it takes 2 pi to get all the way through one rotation of sine. So sine comes up, comes down, and then stops again on that x-axis before it starts to repeat itself, and that takes 2 pi length. Okay, that's your period. Your amplitude is the height of your function, okay? So the greatest height. Our greatest height was 1 because it was the radius of the circle. You couldn't get further away from the x-axis than the entire length of your radius, which is always just going to be 1. The only time your amplitude is going to change is if we start to alter the function itself. We just graphed sine theta, okay? But if we start putting numbers on this, like we start putting numbers in front or inside, different things to these values, then it's going to change some of these. But if it's just regular sine or regular cosine, your amplitude is 1 because you're not going to get any bigger than that radius of your circle, okay? And then the other thing is your minimum, which is pretty straightforward. It's the same thing. It's just how far down do you go, which is going to be -1 because, again, that radius is just 1. So for down, the minimum is going to be a -1. Frequency is how many times your graph appears within 360 degrees or 2 pi. Right now it's 1 because we haven't messed with it, okay? But it's going to change based on different variations of our functions. We're going to do more with that later, but right now we're saying within 2 pi, how many times does this rotate? We go back up here, period and frequency are very closely related. They're just asking 2 different questions, but it's the same concept. How fast is your graph moving? So like right now we're just moving 1 rotation within 2 pi, okay? But pretty soon we're going to speed it up and we might do 2 rotations within 2 pi. Okay, so it's going to get faster. We could go slow and do half of a rotation within 2 pi. So these graphs are going to get stretched and shrunk and moved around a little bit. And that will change the frequency and the period. But right now our frequency is 1 because there's only 1 full rotation within 2 pi. Okay? So there are 6 questions on the first page of your spaghetti lab. Do those 6 questions first and turn those in. Okay, and then we'll do the other 6 questions later and turn those in separately. So just the front page, the first 6 questions on your spaghetti lab.